We're now going to look at degrees and radians and how to convert degrees into radians or radians into degrees. After that, we're going to look at terminating angles in each quadrant. So just make sure you're taking down the notes as I go along and the examples, and pause the video when it comes to question time. Okay, so first off, pi radians is equivalent to 180 degrees. Okay, so that's a given. So that's why I've put that in a box. Alright, so make sure you have it in a box. Pi radians is equivalent to 180 degrees. So if I wanted to figure out what 1 radian was, I would need to divide both sides by pi. Okay, so that's what I've done to go from here to here. Right, divide across by pi, and you get that 1 radian is equivalent to 180 degrees over pi. That's your starting point, okay, always. Because if I know what 1 radian is, I can get however many radians after that. Okay, again, if I start off and I have pi radians is equivalent to 180 degrees, that's always going to be my starting point. If I want to figure out what 1 degree is equivalent to in radians, well then I'm now going to divide both sides by 180. So by dividing both sides by 180, I end up getting what 1 degree is equivalent to in radians. So 1 degree is equivalent to pi all over 180 rads, okay, radians, rads for short. So depending on what way the question asks, like if the question gives you radians and they ask you to convert it into degrees, well then you need to know what 1 radian is equivalent to in degrees. If a question gives you degrees and they want you to convert it into radians, well you'd need to know what 1 degree is equivalent to in radians before you can get any other amount of degrees. So let's look at an example. Convert 290 degrees into radians. So again, your starting point, pi rads is equivalent to 180 degrees. So I want to convert degrees into radians. Well then I need to know what 1 degree is equivalent to. So divide both sides by 180, and that will give you what 1 degree is equivalent to in radians. So if 1 degree is pi over 180, in order to get what 290 degrees is, multiply both sides by 290. Okay, so we're multiplying both sides by 290, and that leaves me with 290 degrees is equivalent to pi over 180 multiplied by 290, and then you just tidy up the fraction. Okay, so 290 pi all over 180 simplifies down to 29 pi all over, that should be 18, not 180, so that's 29 pi all over 18. Alright, so 290 degrees is now equivalent to 29 pi all over 18 rads. If they ask you to give your radians in decimals, right, if they don't specify, well then you leave it as 29 pi over 18 radians. But if they asked you to give it to radians, or give it in degrees, if they ask you to give it in radians and to a certain number of decimal places, well then plug 29 pi over 18 into your calculator and it will give you back 0.5061 ... radians. Okay? Next example. Convert 16 pi over 3 radians into degrees. So again, I want to convert radians to degrees. That means I need to know what 1 radian is equivalent to first, before I can get 16 pi over 3 radians. So your starting point, pi radians is equivalent to 180 degrees. So if I know what pi radians is, in order to get what 16 pi over 3 radians is, all I'm going to do is multiply both sides by 16 over 3. Okay, so I'm multiplying both sides by 16 over 3. Now I get 16 pi over 3 radians is equivalent to 960 degrees. Okay, so it's very straightforward. Right, pause the video now and I want you to go and work on these questions. So question part A, I suppose we'll call this A and we'll call these B. Alright, so questions A, converting radians into degrees, and in question B, you're converting degrees back into radians. So pause the video. Here are the solutions. So 5 pi over 18 radians. So again, your starting point, pi over 18 radians is equivalent to 180. Multiply both sides by 5 over 18 to get what 5 pi over 18 radians is, and then just simplify your answer. So you end up getting 50 degrees. Next one, 4 pi over 3 radians. Again, your starting point, pi radians is equivalent to 180 degrees. If you want to get 4 pi over 3 radians, you're multiplying both sides by 4 over 3. Tidy it up and you get 240 degrees. Last one, 11 pi over 6 radians. Again, your starting point. Pi radians is equivalent to 180 degrees. Multiply both sides by 11 over 6 and you'll get out your 330 degrees. Section B, part 1. 15 degrees. Okay, so your starting point again. Pi radians is equivalent to 180 degrees. But this time you want to convert degrees into radians. So you'd need to know what 1 degree is equivalent to first. So divide both sides by 180 first, and you'll get 1 degree is equivalent to pi over 180 radians. Okay, so that's this point here. Now that I know what 1 degree is, I can get any amount of degrees after that by multiplying both sides by 15. So that's what I've done here. Okay, I've multiplied both sides by 15. So 15 degrees is equivalent to 15 multiplied by pi over 180, and just simplify the fraction. You end up getting pi over 12 radians. Part 2, 35 degrees. Again, your starting point. You need to know what 1 degree is first, so divide both sides by 180. That will give you 1 degree is equivalent to pi over 180 radians. Now you want to get what 35 degrees would be equivalent to. Multiply both sides by 35 and tidy up your fraction. You end up with 7 pi over 36 radians. And again, remember, if the question had asked you to give your answer in decimals, well then just plug 7 pi over 36 into your calculator and it'll give you back the decimal equivalent. Part 3, 37.5 degrees. Same thing again, just because you now have a decimal in your degree, it doesn't change anything. So your starting point, pi radians is equivalent to 180 degrees. Divide both sides by 180 so that you can get what 1 degree is equivalent to. Then multiply both sides by 37.5 to get what 37.5 degrees is equivalent to. And just tidy up your fraction. You end up with 5 pi over 24 radians. Okay, and that's given in its simplistic form. Last one, 980 degrees. So again, your starting point, pi radians is equivalent to 180, not 980, right? 180 degrees. Divide both sides by 180, and that will give you what 1 degree is equivalent to, and then multiply both sides by 980, and you'll get out 49 over 9 pi radians as your final answer. Okay, we're now moving on to terminating angles. So what I mean by terminating angles, it just means which quadrant do the angles finish in. Okay, so you're always going to start at 0 degrees on the positive side of the x-axis, and you're going to move in an anti-clockwise direction in order to arrive at your angle. Okay, so here's my xy axis. All right, so just for example, right here, this is 0 degrees. You move 90 degrees in this direction. Another 90 brings you down to 180. Another 90 brings you to 270. And a final 90 brings you back to 360 degrees, and you're back at the x-axis again. Okay, so just remember we're going in an anti-clockwise motion to arrive at our angle, to see which quadrant will it terminate in. Remember the 4 quadrants. Okay, first, second, third and fourth in that order. So it's important that you remember the quadrants. Let's look at this example. In which quadrant will 420 degrees terminate? So always just remember, a full rotation is 360 degrees. Alright, so if you can get 1 full rotation, sure, that's going to bring you back to the positive side of the x-axis again. And then you keep going until you get the remainder of your angle to see where do you end up. So what we can do is continue to subtract a full rotation from our angle that we were given until we arrive at a value that is less than or equal to 360 degrees. Okay, so any value we end up arriving at between 0 and 360 degrees inclusive, that tells us the angle that we're really looking for. Okay, so 420 degrees, if we subtract a full rotation from that, we end up with 60. So really what we want to know is which quadrant does 60 degrees lie in? Okay, because that would tell us that's the same as where 420 degrees should lie. So let's just look at a diagram. Okay, here's my 4 quadrants, right? If I'm starting at the positive side of the x-axis, so I'm starting at 0 degrees, okay, in the red here. And you can see if I go 1 full rotation, I've now done 360 degrees. All I'd have to do is another 60, and that would bring me up to 420 degrees. Okay. and that 420 degrees, which is equivalent to 60 degrees, is in the first quadrant. So just remember your quadrants again, okay? 1, 2, 3, and 4. So the quick method was to continue to subtract 360, all right, and that told you the angle that you ended up with, okay? And straight away then you can see, well, which quadrant does 60 degrees lie in, because that would be the same as 420. Here are the following questions. Pause the video, follow the questions, and then look at the solutions. Okay, part 1. Which quadrant does 710 degrees lie in? So take 360 off that, so take away a full rotation off that. That leaves you with 350 degrees. I can't take another full rotation off 350 because I'd end up with a negative angle. So 350 lies between 0 and 360, so it's going to end up in the fourth quadrant. And look where I started, right? From here to here, that's 360 degrees. And then another 350 degrees would land me over here at 710 degrees. So I'm in the fourth quadrant. The other part of that question then said, give your answer, or sorry, convert 710 degrees into radians. So your starting point, pi radians, is equivalent to 180 degrees. Therefore, divide across by 180 to get what 1 degree is equivalent to. Then multiply both sides by 710 to get what 710 degrees is equivalent to, and simplify your fraction. So 710 degrees is equivalent to 71 pi over 18 radians. And again, you can give that in decimals if you want by just putting it into the calculator, and it'll give it back in decimals. Part 2, 1080 degrees. So keep subtracting rotations until you get to a final value that lies between 0 and 360 degrees inclusive. So if you take a first rotation off it, that leaves you at 720. I can take another rotation off that, that leaves me at 360. 360 is one full rotation, so I know that's going to land me at the fourth quadrant. Okay, so with my starting point, I go from here to here, and that brings me, that's my first 360 degrees. Another 360 degrees would bring me to 720. And then finally my last 360 degrees brings me right up here, and that's on the fourth quadrant, okay? And I have a little side note here, just to read for yourself. 360 degrees, it's on the x-axis, but it's still in the fourth quadrant. Whereas if you landed at 0 degrees, well, that's in the first quadrant. You'd be starting again from the first quadrant, so just be mindful of that. Right, 360 degrees is on the x-axis, but it's still the fourth quadrant. The third question then, part 3, 840. So subtract a rotation of that, that brings you to 480. Subtract another rotation of that and you're at 120. 120 degrees is the same as 840 degrees, therefore I'm in the second quadrant. And again, look at my diagram. From here to here is 360. From here over to here is 720. And then if I have to go another further 120 degrees, that brings me up to 840, and I'm in the second quadrant. Okay, that's the end of this video.